So is it clear, guys? Yes, how to find the maximum possible error, how to find the maximum possible error in the resultant when more than one operations are involved, more than one operations of physical quantities are involved in an equation. Yes, so now let's discuss some problems on combination of errors. Yes, so this is the last topic, or we can say this is the last section, this is the last part of this particular topic, error. Yes, so the first question is the temperature of two bodies, the temperature of two bodies measured when measured using a thermometer is as follows. Calculate, that is T1, temperature T1 is equal to 20 degrees Celsius plus or minus 0.5 degrees Celsius. Temperature T2 is equal to 50 degrees Celsius plus or minus 0.5 degrees Celsius. Calculate the temperature difference and error in it. Yes, so this question is a very simple question, isn't it? Yes, here you are given two temperature values, and you are asked to find the difference between those temperature values, and the maximum possible error in the resultant, Yes, so let the resultant be T, and we know T is equal to, as per the question, T is equal to T1 minus T2, isn't it? We are asked to find the difference between these two temperature values. Yes, so while finding the difference between two temperature values, yes, how do we find? So here I am going to substitute the value of T1 and T2 respectively. So here T1 is nothing but 20 degrees Celsius plus or minus 0.5 degrees Celsius. Again minus 50 degrees Celsius plus or minus 0.5 degrees Celsius. 50 degree plus or minus. Okay, let this be 50 because T2 is greater than T1, isn't it? T2 is greater than T1. So let this be T2 minus T1. So 50 degrees Celsius plus or minus 0.5 degrees Celsius minus 20 degrees Celsius plus or minus 0.5 degrees Celsius. So here we are asked to find the temperature difference and error in it. We are asked to find the temperature difference and error in it. We can say the temperature difference is nothing but the difference between the actual value, and the error is nothing but the sum of the absolute errors, or sum of the positive error values in individual measurements. Yes, so here we got the temperature, actual temperature as 30 degrees Celsius plus or minus 1 degree Celsius. So here the temperature difference value is equal to 30 degrees Celsius, and the error involved, or the error arised, or we can say the error occurred in the resultant, is 1 degree Celsius. Is it clear? Yes. So this was a very simple question. Here you have to apply the concept of error combination when two physical quantities are subtracted. If suppose here you are asked to find sum of the temperature. Here you are asked in this question, temperature difference. If suppose in the question you are asked sum of the temperature, you are asked to find the sum of the temperature, then how do you find? Only one difference is here. Here you are subtracting 20 from 50 because you are asked to find temperature difference. If you are asked to find the sum of the temperature, instead of subtracting 20 from 50, you have to simply add these two temperatures. Thus the value become 80 degrees Celsius plus or minus 1 degree Celsius. There is no change in the maximum possible error. There is no change in the maximum possible error because both in the cases, that is when physical quantities are added or when physical quantities are subtracted, for finding the maximum possible error or finding the maximum absolute error in the resultant, we have to simply add the absolute errors in individual measurement, or we have to add the positive values of the errors in the individual measurements. Is it clear? Yes. The next question, the resistance R is equal to V by I. R is resistance and V is voltage and I is current. Yes. Where you are given the values of voltage and current, that is V is equal to 100 plus or minus 5 volt and I is equal to 10 plus or minus 0.2 ampere. Yes, as I told you before, while doing problems you have to consider the units also. Here you need to have same units. In the actual measurement, and error. Is it clear? Yes. Otherwise while combining the errors, yes, you have to convert all the units, you have to convert all the values into a single unit. Is it clear? Yes. Find the percentage error. Find the percentage error in R and find the absolute error in R. Find the absolute error in R and find the percentage error in R. R is nothing but resistance. Okay. Here. So, here you are given two values. That is, one is voltage. Here it is given 100 plus or minus 0.5, not 0.55. 100 plus or minus 5 whole bracket volt. It means this volt is this particular unit volt is applicable to both 100 and 5. Is it clear? So 100 plus or minus 5 whole bracket volt means nothing but 100 volt plus or minus 5 volt. Yes. Again, I is equal, it is also given. Similarly, I is also given as 10 plus or minus 0.2 whole ampere. It means this A is applicable to both 10 and 0.2. So we can say 10 ampere plus or minus 0.2 ampere. So here both the units are in errors, and the units in errors and actual values are same. So there is no need of unit conversion here. If the units are not same, yes, please remember you have to convert all the values to a single unit. Yes. So here it is given R is equal to V by I. Yes. So R is our resultant. Here we are dividing two physical quantities. to get the value of resultant. So when we are dividing two physical quantities, or when we are multiplying two physical quantities, we know the relative error in the resultant is equal to the sum of the relative error in individual measurements, isn't it? Yes. So here what is the relative error in R? Del R by R. del R by R is equal to relative error in voltage plus relative error in I. Relative error in voltage plus relative error in I. Yes. How do you find the relative error in voltage? Relative error in voltage is nothing but error divided by actual value. Here also there is no need of writing unit because since both the units are same, they will get cancelled. Here also error in current divided by actual value. So you get the value as 5 by 100. Here we can say it is given 2 by 100. So 2 by 10. So we can say it is 2 by 100. So 5 by 100 plus 2 by 100, that is equal to 7 by 100. 5 by 100 plus it is given 0.2 divided by 10. It is given 0.2 divided by 10. Say we can write what is 0.2 divided by 10. 0.2 divided by 10 is nothing but 0.02. So how can we write 0.02? We can write otherwise 0.02 can be written otherwise as 2 by 100, isn't it? 2 by 100 is equal to 0.02. So 0.02 and 2 by 100 is one and the same. So I wrote 0.2 by 10 as 2 by 100. So here both the denominators are one and the same. So when we are adding fraction values, if both the denominators are one and the same, yes, we have to simply add up the numerator. We have to simply add up the numerators in both the fractions and write the common denominator. Write the common denominator as the denominator of the resultant fraction. So when I added 5 by 100 and 2 by 100, I got the value 7 by 100. Thus I found the relative error in resistance. Yes. Here in this question I am asked to find the percentage error in resistance. So how do we find the percentage error in resistance? What is percentage error? Percentage error is nothing but relative error expressed in percentage. So here I got the value. Let percentage error in R be del R. Percentage error in R be del R. So del R is equal to relative error into 100. That is equal to 7%. Is it clear, guys? Yes. Now the next question is to calculate absolute error in R. How do you calculate the absolute error in R? We know relative error is equal to absolute error divided by actual value. Relative error is equal to absolute error divided by actual value. So here we can say del R is the actual value. Del R is the absolute error and R is the actual value. Del R is the absolute error and R is the actual value. Here actually I have to find what is del R is equal to. So del R is equal to actual value of R into relative error in R, isn't it? Actual value R into relative error in R. I got the value of relative error in resistance as 7 by 100, isn't it? I got the value of relative error in resistance as 7 by 100. So how do I find the actual value of R? It is very easy. For finding the actual value of R, yes, you have to simply divide the actual value of voltage by the actual value of current, that is equal to actual value of voltage by actual value of current, that is equal to 10 ohm. Unit of resistance is ohm. Okay, yes. So here I got the value as 10 ohm. So these two will get cancelled. So 0.7. So the absolute error in resultant R, is nothing but 0.7 ohm, and the relative error in the resultant R is 7 by 100, and the percentage error in resultant R is equal to 7%. Is it clear, guys? Yes. Yes, all the points that we are applying, or all the concepts that we are applying while solving these problems are something that we discussed earlier, isn't it? Yes, we are simply applying the concepts that we discussed in the previous videos or previous sessions or previous topics. Yes. Now, here there are two resistors. There are two resistors whose resistance values are two resistors R1 and R2. Okay, two resistors R1 and R2 whose resistance values are 100 plus or 100 ohm plus or minus 3 ohm and 200 ohm plus or minus 4 ohm respectively. Okay, respectively. Yes. So, what is the absolute error? What is the absolute error in the resultant resistor? Absolute error in the resultant resistance when these two resistors are connected in parallel and in series. So here in this question you are given two resistors. Two resistors are having resistance values 100 ohm plus or minus 3 ohm and 200 ohm plus or minus 4 ohm. And here you are asked to find the absolute error. Here it is given only absolute error. Okay. Both absolute error and resultant resistance. Here you are asked to find the absolute error and resultant resistance. The absolute error and resultant resistance. Let this question be like this: absolute error and resultant resistance. Absolute error and resultant resistance when the two resistors are connected in series and when the two resistors are connected in parallel. So you are given two resistors R1 and R2 whose resistor values are 100 ohm plus or minus 3 ohm and 200 ohm plus or minus 4 ohm. Yes. Let the resultant resistance be R resultant. Is it clear? Yes. Here actually we have to find the resultant resistance. When these two resistors are connected in series and parallel. So first let's find out the resultant resistance and absolute error when they are connected in series, because series is comparatively easy. When two resistors are connected in series, the resultant resistance is equal to the sum of the individual resistance values. Is it clear? Yes. So here we know for finding the absolute, for finding the absolute error in the resultant, you have when two physical quantities are added. When we are adding two physical quantities, yes, we have to simply add the absolute error in the individual measurements. So what is the absolute error in the individual measurements of R1? Absolute error in the individual measurement of R1 is 3 ohm and absolute error in the measurement of R2 is 4 ohm. absolute error in the resistance value 100 ohm plus or minus 3 ohm is 3 ohm, and in the next one 200 ohm plus or minus 4 ohm is 4 ohm. So we can say the maximum possible error or the absolute error in R resultant is equal to 7 ohm. The absolute error in R resultant is equal to 7 ohm. Is it clear? Yes, for finding we know for finding the maximum possible error or absolute error in the resultant, when two physical quantities are being added, we have to simply add up the absolute errors or positive values of the errors in the measurements, in the individual measurements of the physical quantity. Yes. Okay. So we got the absolute error in the resultant as 7 ohm. So thus we found the answer for the first question, that is absolute error when resistors are connected in series. Now we have to calculate the resultant. If you are asked to find any resultant value, it consists of two parts. That is, the first part is the actual value of the resultant. And the second part is absolute error of the resultant. Is it clear? When you are asked to find the value of resultant, when you are asked to find the measurement or measure or value of the resultant, yes, it consists of two parts, or we can say it consists of two components, and the first one is the actual value of the resultant. And the next one is absolute error. Is it clear? So here we have already found out the absolute error in the resultant. Now the pending one is actual value, isn't it? So what is the actual resistance value? As I told before, when two resistors are connected in series, yes, the resultant is nothing but the sum of those two resistor values. So we can say actual value of resistance is equal to sum of 100 ohm and 200 ohm, that is equal to 300 ohm. This is the actual value. So thus we found the two components in the resultant resistance, that is actual value and error. So what is the resultant resistance? R resultant is equal to 300 ohm plus or minus 7 ohm. 300 ohm plus or minus 7 ohm. Is it clear? So what is resultant resistance? Yes. So how do we find the resultant resistance when two resistors are connected in series? Yes. Now let's see how to find the resultant resistance when two resistors are connected in parallel. Yes. So when two resistors are connected in parallel, the resultant resistance R resultant is equal to 1 by R1 plus 1 by R2. 1 by R1 plus 1 by R2. Is it clear? Yes, when two resistors are connected in parallel, the resultant resistance is equal to 1 by R1 plus 1 by R2. Yes, here we know R1 is equal to 100 ohm. Here we know R1 is equal to 100 ohm plus or minus 3 ohm, and R2 is equal to 200 ohm plus or minus 4 ohm. Since there is some error in both of these measurements, yes, obviously some error will arise or some error will occur in the resultant also. So we can write this particular equation as 1 by R resultant plus del R resultant. So we can write this particular equation as 1 by R resultant plus del R resultant is equal to 1 divided by R1 plus del R1. 1 divided by R1 plus del R1 again plus 1 divided by R2 plus del R2. 1 divided by R2 plus del R2. Is it clear, guys? Yes. Clear, guys? Yes. Now the next step is I am going to take the actual value. I am going to take actual value from actual value commonly outside. I am going to take the actual value commonly outside from each of these denominator values. Is it clear? That is 1 divided by R resultant. So how do we take a value? How do we take a value commonly outside? Yes, we have to simply divide we have to simply divide all the terms by this common value, isn't it? So I am going to divide R resultant by R resultant. So I will get 1 plus del R resultant divided by R resultant. So this particular fraction 1 divided by R resultant plus del R resultant has now become 1 divided by R resultant into 1 plus del R resultant divided by R resultant. Similarly, I am going to take this R1 commonly outside from this denominator and R2 commonly outside from this denominator. So I will get R1 into 1 plus del R1 by R1, again plus 1 divided by R2 into 1 plus del R2 divided by R2. Yes. So is it clear, guys, up to this? Yes. Now let me rub this question. Now I am going to, if suppose it is given 1 into x by y. If suppose it is given 1 divided by, not 1 into, 1 by x into y. If suppose it is given 1 by x into y, we can write this particular term as y inverse divided by x. That is the term y. I brought the term y in the denominator to the numerator. When we bring a term from numerator to denominator or from denominator to numerator, yes, we know, yes, we have to inverse the power value, isn't it? We have to inverse the power value. Say for example, if suppose it is given y divided by x. If suppose it is given y divided by x. Here in this case y is in the numerator and I have to take, or I have to bring this y to the denominator. So how can I write x divided by y inverse? Is it clear? 1 divided by xy inverse. Is it clear? Yes. If suppose we have 1 divided by x into y square, we have 1 divided by x into y square, I have to bring this y square in the denominator to the numerator. So we can say I will get y to the power minus 2 divided by x. Is it clear? Yes. So here also we have 3 terms in the form. 1 divided by x into y. So here I am going to bring, this particular term, in brackets from denominator to numerator. So I can write 1 plus del R resultant divided by R resultant, the whole inverse, divided by R resultant is equal to 1 plus del R1 by R1, the whole inverse divided by R1. Again plus 1 plus del R2 by R2, the whole inverse divided by R2. Is it clear, guys, this step? Yes. Now, when we discussed the case 4, that is how do errors get combined? When we discussed case 4, that is how do errors get combined when we are dividing two physical quantities? We learned an equation 1 plus here plus or minus, we have plus or minus, isn't it? Yes, here we have plus or minus. So 1 plus x the whole inverse is equal to 1 minus nx plus 1 minus x plus x square minus x cube plus etc. It goes on like this, isn't it? All the values, all the terms are having even powers will be positive, and all the terms having odd powers will be negative when we are finding 1 plus x the whole inverse. Do you remember this, guys? Yes, when we discussed the case 4, that is how do errors get combined when we are dividing two physical quantities. Yes, we discussed about binomial equation, their expansion, and this particular special case, isn't it? Yes. So here we are going to, here in this case all of these three terms, are in the form of 1 plus x the whole inverse. In the place of x we have del r by r resultant in the first term, del r1 by r1 in the second term, and del r2 by r2 in the third term. So we are going to expand these three terms. These three terms. Okay. Yes. So we know what is 1 plus or minus del r resultant by r resultant. We know it is 1 minus del r resultant divided by r resultant. 1 minus del r resultant divided by r resultant plus del r resultant by r resultant the whole square minus del r resultant by resultant the whole cube, etc. Just like in the case of division, yes, here also we can neglect all these terms. Starting from power value 2 to n, up to the end. Is it clear? Why we can neglect all these terms? Because del r is extremely smaller. When we are finding the square value of del r, yes, we will get yet even more extremely smaller value. Again, we know r is extremely larger. The value of r is extremely larger. When we are finding the square, we will get yet more or even more larger value. So when we are dividing extremely smaller value by a very larger value, yes, obviously we will get a very smaller value. So this particular value has little or no effect. In the resultant. So we can neglect or ignore all these terms starting from the power 2 up to the end. Is it clear? Yes. So what is 1 plus or minus? Del r resultant by r resultant whole inverse. We can say 1 minus or plus del r resultant divided by r resultant the whole divided by r resultant. Is it clear, guys? Similarly in the case of these two terms, we can write it as 1 minus or plus del r1 by r1 divided by r1. Again 1 minus or plus del r2 divided by r2 the whole divided by r2. So is it clear, guys, up to this? Yes. Now I am going to divide these two terms. I am going to divide these two terms individually by this common denominator. So I will get 1 divided by r resultant minus or plus del r resultant divided by r resultant into r resultant. Is it clear, guys? If it is given x plus y divided by z, if possible you can add these two values, and then you can divide the resultant by this particular denominator. Otherwise you can write x plus y the whole divided by z is equal to x by z plus y by z. This common denominator is applicable to both of these terms. This common denominator is there for both of these terms. So we can write x divided by z plus y divided by z. Suppose if it is given x divided by y by a divided by z, let here also b. So how do you write this? You can write this as x divided by z into b plus y divided by z into a. Is it clear, guys? So is it clear, guys? Yes, this is what we did here. Yes. Similarly, we can do this. You can do this same operation on the other side of the equation also. That is, I am going to divide this r1. I am going to divide both of these terms by r1. That is equal to 1 by r1 plus minus or plus del r1 by r1. Again, plus 1 by r2 minus or plus del r2 by R2 into R2. Is it clear, guys? Yes. So here we know R resultant is equal to R resultant square. So here I can write R resultant square. Here also I can write R1 square, and here I can write R2 square. Is it clear, guys? Yes. Now we know here we have 1 by R resultant. On the left side of the equal sign, we have 1 divided by R resultant, and on the right side we have 1 by R1 plus 1 by R2. Isn't it? We have 1 by R1 and 1 by R2, and we are adding those two terms. So we know 1 by R resultant is equal to 1 by R1 plus 1 by R2. So these values are one and the same. These two values are one and the same. So we can cancel these values. We can cancel these three terms. So now our equation becomes like this. That is, now our equation becomes like this. That is, del R resultant divided by R resultant square is equal to del R1 divided by R1 square plus del R2 divided by R2 square. Is it clear? Yes. Here for finding the maximum, here we are finding the maximum possible value. So here actually we have to consider only the positive values. So now I am going to substitute. The values. Now I am going to substitute the values for finding the absolute error. Now I am going to substitute the values for finding the absolute error del R resultant. So here from this equation, yes, we can find del R is equal to R resultant square into del R1 by R1 square plus del R2 by R2 square. Is it clear, guys, up to this? Now I am going to simply substitute all the values. First, let's substitute the values in the bracket. What is del R1? What is the value of del R1? Let me see the question. The value of del R1 is 3 and the value of R1 is 100 square, isn't it? Plus the value of del R2 is equal to 4 and it is 200 square. Okay. So here in this case, we know the values of del R1, del R2 and R2. How do we find the resultant resistance? Actual value of the resultant, how do we find? We know when two resistors are connected in parallel, 1 by R resultant is equal to 1 by R1 plus 1 by R2. Otherwise, we can say when we solve this equation, we get R1 plus R2 divided by R1 R2, that is 1 by R resultant is equal to R1 plus R2 divided by R1 R2 is equal to 1 by R resultant. So from this equation, how can we find R resultant? Just finding the inverse, or just taking the inverse, that is R resultant is equal to R1 R2 divided by R1 plus R2. Is it clear, guys? R1 R2 divided by R1 plus R2. Simply substitute the values of R1 and R2, that is 100 into 200 divided by R1 plus R2. So these two zeros will cancel. 200 by 3. 200 by 3 is our actual resultant resistance. 200 by 3 is our actual resultant resistance. So here we have to find the square of the actual resultant resistance. So 200 the whole square. Is it clear? Yes, 200 by 3 the whole square. Now let's find what is each term is equal to 200 divided by 3 square. So I got the value. Let me rub this. Okay. Second case is actually a very lengthy one, isn't it? Yes. It seems to be difficult. But once you understand it, it's very easy. It's not as difficult as it seems. So here we have to find del R resultant value. Del R resultant value. We already found R resultant when two resistors are connected in parallel, that is 200 by 3, 66.66. Now the square of this particular value is 22.22. Now I am going to find 3 divided by 100 square, that is equal to 0.003 plus what is 4 divided by 200 square, that is equal to 0.001. Okay, 0.001. Yes. Now 0.0003 plus 0.001, that is equal to, okay, into 22 is equal to 0.0088. So is it clear? 0.0088. So thus we got the absolute error. Am I right? 3 divided by 100, 4 divided, are the values same? 3 divided by 100, 4 divided by 200. Yes. Again. So here the resultant will be, let me check once more, 100 into 200 divided by 300. So these two can cancel. 200 divided by 3. Fine. So again 200 divided by 3. 200 divided by 3 the whole square. Sorry, here it is not 224. Sorry. Here we will get the value as 44444.4. So now let me check. 44.4 into 0.03 plus 0.001. So I am getting the value as 1.77. I am getting the value as 1.77. Yes. Here I got the absolute error value. Or simply error or maximum possible error as 1.77. Maximum possible error as 1.77. And the actual resultant resistance is 6.66. So we can say the resultant resistance is equal to 6.66 ohm plus or minus 1.77 ohm when two resistors are connected in parallel. Is it clear, guys? And when two resistors are connected in series, we got the value as 300 plus or minus 7 ohm. When two resistors are connected, the first one is parallel and the second one is series. Is it clear, guys? Yes. Okay. So So here let's see a quick recap. Let's see a quick recap of this question. Here you were provided with two resistor values and you are asked to find the absolute error and resultant resistance. Not the actual resistance value, but you are asked to find the resultant resistance. When we are asked to find the resultant of some physical quantity, yes, it consists of two components. The first one is the actual value of the resultant and the second one is the error or absolute error. Is it clear? Yes. So the first case was when two resistors are connected in series. When two resistors are connected in series, yes, the resultant resistance is equal to the sum of those two resistance. So it is very easy to calculate the absolute error. It is very easy to calculate the absolute error and the actual measurement. Yes, and we got the value as 300 plus or minus 7 ohm. Is it clear? We simply added the actual values in individual measurements, and then we simply added the absolute errors or positive values of the errors in the individual measurements to get the resultant resistance when they are connected in series. Is it clear? When they are connected in parallel, yes, the process was little complicated, or we can say the process was little lengthy. So we know when two resistors are connected in parallel, the resultant resistance 1 by R resultant resistance is equal to 1 by R1 plus 1 by R2. Here we have some error in the value of R1 and we have some error in the value of R2. So we know obviously some error will arise or some error will occur in the resultant. So we can write or we can modify this particular equation as 1 divided by R resultant plus del R resultant is equal to 1 divided by R1 plus del R1 plus 1 divided by R2 plus del R2. Is it clear up to this? Now the next step is I took the actual values in the measurement commonly outside from each of these terms. Yes, I took the actual value outside from each of these measurements commonly outside. Then I took the inverse, or I got the term in the form 1 divided by, so the term, or we can say, yes, so the term has now become 1 divided by x into y. Term has now become in the form 1 divided by x into y. Yes, we can rearrange the terms, or we can rearrange the variables in this particular term as y inverse by x. That is, I simply brought the value, or I simply brought the variable or term, whatever it may be, in the denominator to the numerator. When we bring a term from numerator to denominator or denominator to numerator, yes, the power get inversed. If the power is positive in numerator, when it comes to denominator it becomes negative, and vice versa. If the power is negative, when it comes to the other side it becomes positive. Here in this case the power of y is 1. So when I brought this y in denominator to numerator, the power become inverse. Is it clear? And my term was in the form of 1 plus x the whole inverse. All of those three terms that I brought from denominator to numerator was in the form of 1 plus x the whole inverse. I know for x, when we expand this particular term, we will get like something like this, isn't it? Yes, all the terms having odd powers will be negative, and all the terms having even powers will be positive. So I substituted the resistance values in this x in the place of x. Yes. Thus I got some extremely smaller terms. So when I substituted the value of x, in all of those cases, yes, I got some extremely smaller values which has some negligible effect or very little effect on the resultant, starting from the power 2 to 2 up to n. So I neglected all those terms starting from power 2 up to n. Is it clear? So my equation become in the form 1 minus x. My equation become in the form of 1 minus x. Again, after this I divided the whole term, or I divided each of the term. I divided each of the term in the numerator by the common denominator. After this step, I divided all the terms or each of the term in the numerator by the common denominator. So I got the equation. I got equation something like this, R 1 by R resultant. I got the equation something like this, 1 by R resultant, 1 by R resultant plus 1 by R resultant minus or plus del R resultant divided by R resultant square is equal to 1 by R1 plus 1 by R2 minus or plus del R1 divided by R1 square minus or plus del R2 divided by R2 square. We know 1 by R resultant is equal to 1 by R1 plus R2. So all these three terms get cancelled. Here we are finding the maximum possible value. So we know for finding the maximum possible when we have multiple cases and we have to find the maximum possible value, yes, we will consider only the positive values, isn't it? We consider only the positive values and add them up. So I got an equation like this. Now for finding del R resultant, I brought this to the other side of the equation. Here, if we are dividing a term on one side of the equal sign, when we bring this term to the other side, we have to multiply. So I got the equation as del R resultant is equal to R resultant square, and in brackets del R1 by R1 square plus del R2 by R2 square. I found the value of R resultant using the equation R1 R2 divided by R1 plus R2. Simply substituted the values given in the question for R1 and R2, actual values. Again here I substituted the values for del R1, del R2, R2. Once I solved the equation, yes, I got the resultant resistance when they are connected in parallel. Is it clear? Yes. I hope this particular question is clear to you. If you have any doubts, yes, please watch this session once more. Still, if you have doubts, yes, please do ask in the comment section. Yes. In some cases, or we can say in some questions, yes, direct applications of equation, direct application of the formulas that we learned won't say. Okay, yes, in such situations, yes, we have to find alternative methods like this. Is it clear? Yes.